I welcome you in the discussion of CSIR NET question paper. The questions came on stereochemistry and conformational analysis from 2015 onwards. We are going to discuss. Now, the question is like this: the most stable conformation for the following compound. They have given one compound, that is cyclohexylidene derivative, and if we investigate the four options, then it is clear that the third option and the fourth option we have to cancel, because the third option there is one boat form and in the fourth option there is a twist shear form. So now the leftover option 1 and the 2, if we investigate, then in the option 2 if there is allylic 1,3 strain, so that makes the conformer unstable. Hence our final answer will be option 1. Now coming to the next question of the 2015, that we have to identify the correct relation between the two substituted allenes, and these substituted allenes are having chiral axis as well as the chiral center. So we have to do the RS nomenclature for the axial chirality as well as the chiral center, and then we have to identify whether they are enantiomers, diastereomers, homomers, or the constitutional isomers. Now, without doing anything, it is very clear that they cannot be the constitutional isomers because they do not differ in the bond connectivity. Hence, the option 4 is not possible. Now, before doing the RS nomenclature for the chiral axis, let us first do the RS nomenclature for the chiral center. Now, if the structure which is in the left hand side, if we see the chiral center, which is the first priority, that allene side is the second priority, methyl is the third priority, and the hydrogen which is not seen, that is below the plane. So that is the fourth priority. So fourth priority group is below. So therefore OH first priority to the double bond, second priority, methyl third priority. This is clockwise. So it has the R configuration. Now coming to the right hand side, that structure. So here fourth priority group is above the plane. So we have to consider in the opposite way. So OH is the first priority, double bond second priority, methyl third priority. They are actually arranged in the anti-clockwise. So here also it is R. So both the chiral centers have the R absolute configuration. So therefore we can rule out the first option also. Already we have ruled out the fourth option. Now we are removing the first option. Why? Because they cannot be the enantiomers, as the chiral center has the same absolute configuration. So the leftover is the either they will be diastereomers, otherwise they will be homomers. So now for doing the RS nomenclature for the chiral axis, both the cases it is coming as the S, so therefore they are not the diastereomers. The two structures which they have given, those are homomers, so the final answer is 3. Now coming to the next question of 2015, identify the two enantiomers among the following compounds. They have given the 4 compounds A, B, C, D. All of them they have the same formula and they only differ in the orientation of the chiral centers. This compound contain the 2 chiral center, and formula wise this is CH3, CHBr, CHBr, CH3 means 2,3-dibromobutane. Now, if we investigate the structure of this 2,3-dibromobutane, then it is clear that this compound contains 2 chiral centers, and these 2 chiral centers are of similar type. Now, if we do the RS of these 2 centers in the A, B, C, D 4 structures, then only it will be clear out of them which are the enantiomers. Now, when we are doing, bromine is the first priority, the chain is the second priority, methyl is the third priority, and the hydrogen is the fourth priority. Now, wherever hydrogen is below the plane, in that case 1, 2, 2, 2, 3 clockwise means R, where the hydrogen fourth priority is above the plane, in those cases 1, 2, 2, 2, 3 if it is clockwise, then S, 1, 2, 2, 2, 3 if it is anti-clockwise, it is R. So by applying all these concept A, B, they are coming actually, the reverse key it is coming, means the center which is S, in the B it is coming as R, which is R in A, that is S in B. So this has a combination of the RS. Now, as because the 2 chiral centers are repetitive, so what is RS? That is only SR, means the plane of symmetry passing through the center. So this molecule is achiral, and these A and B, they are homomers, they are the meso 2,3-dibromobutane. Now coming to the C, the two centers have the absolute configuration RR, and coming to the D, those two are SS. So one is RR, another one is SS. So these two are only pair of enantiomers. Hence our final answer is the fourth option, because there they have given the C and D. So C and D are the pair of enantiomers. A and B, they are the homomers. A, C, B and D, they are the diastereomers. Now coming to the next question, which appeared in the December 2015, we have to identify the major products A and B in the following reaction. That is one cyclohexane's derivative is there, which is subjected to the pyrolysis at 180 degree centigrade, and another one is 160 degree centigrade. When 180 degree centigrade, the product is A, and 160 degree centigrade, there is product is B. First of all, what is E? The A, that is only B. Means by heating in 20 degree difference, 180 degree and 160 degree centigrade, we are not going to get the two different compounds. So option 1 and option 2 are not possible, where A and B are the different. Now coming to the third and the fourth, any one will be the final answer. Now the given question, which is actually the pyrolytic elimination of N oxide to give us one alkene. This is a popular name reaction which is known as the Cope reaction. In this regard, I would like to mention this is Cope reaction, not Cope rearrangement. And in the Cope reaction, the nitrogen oxide under pyrolytic condition, means after under thermal condition, it undergoes the scene elimination, means the groups will undergo the same side elimination. Means if the two groups are same above the plane, then those two groups will be eliminated, or if the two groups are below the plane, then those two groups will be eliminated. So this is a characteristic of this Cope reaction, which is an example of the scene elimination. And another characteristic of the Cope reaction is the Hoffman product, means Selchuk product will not form. We know the Selchuk product means the thermodynamically more stable, more substituted product, which will not form here. Hoffman product will form, means which is thermodynamically less stable, kinetically controlled product, less stable product will form. So this reaction ki answer is, first we have to apply Cope reaction, next we have to consider scene elimination, next we have to understand the Hoffman product, means the less substituted alkene will be the major product. So now if we investigate the given option 3 and 4, then in the third option, it's a less substituted alkene because it's a disubstituted alkene, whereas in the fourth option, it is a trisubstituted alkene, which is the Selchuk product. So the fourth one is not the answer. Our final answer is the 3. Now coming to the question appeared in the 2014, that the amino acid constituents of artificial sweetener given below are this. So this compound is artificial sweetener, and although in the question it is not given that actually this compound is aspartame. So from name it is very clear that it will be the one component will be aspartic acid. So based on this, the option A is not possible because their aspartic acid is not given. Now in this case, the N-terminal amino acid is actually the L-aspartic acid, and the right hand side part means that C-terminal amino acid is the phenylalanine. So therefore this combination is available in the option B. So therefore our final answer is that aspartame contains L-aspartic acid and L-phenylalanine. Now coming to the another question in the 2014, that is in the most stable conformation of neomenthol, stereochemical orientation of the three substituents on the cyclohexane are. So there are three substituents are there in the cyclohexane. One is OH, one is isopropyl, and the third one is the methyl. So they have given the various combinations of orientations of OH, isopropyl and the methyl. And if we draw all these given options, I mean 1, 2, 3, 4, then there are 4 diastereomers are possible. The first one is OH, isopropyl, methyl, all are equatorial, and that represents the menthol. And now coming to the second one, that is OH axial, and the remaining 2 are equatorial, that represents the neomenthol, and that is the final answer. Now moving to the third option, there they have given that OH and isopropyl are equatorial, methyl is axial, and that is isomenthol. And the last option means the fourth option, where the OH is equatorial, isopropyl is axial, methyl is equatorial, that is isoneomenthol. So there are four options, 1, 2, 3, 4. Sequentially they are representing menthol, neomenthol, isomenthol, neoisomenthol, and the given question is based on the neomenthol, hence our final answer is answer 2. Now coming to the next question, appeared in the 2014, that configuration of the carbon atom C3 and C4 in D-ribose respectively. 4 options are given. Now let us first, in order to answer this question, we have to write the D-ribose correctly. So this is pentose family. D means that bottommost chiral center, the OH will be in the right hand side, and all the OHs will be in the right hand side. That represents the D-ribose. Now coming to the numbering, the question they have asked C3 and the C4, means aldehyde carbon is C1, second carbon they did not ask. Third and the fourth, if we do, the OH is the first priority, the top side is the second priority, the bottom side is the third priority, the hydrogen is the fourth priority. Hydrogen is in the horizontal line, so OH to aldehyde side to CH to OH side, this is in the clockwise, so this will be R. So in a exactly similar way, if you go to the C4, they are also the similar type of priority only will come, means OH first priority, the top chain is the second priority, CH2OH is the third priority, hydrogen is the fourth priority. Hydrogen is on the horizontal line, so they are moving in the clockwise direction. 1, 2, 2, 2, 3 is the anti-clockwise direction, so therefore this will be R. So at the C3 and the C4, both the centers are absolute configuration, therefore that option will be 3. Now coming to the next question, the absolute configuration of chiral centers of starting ketone in the following reaction is. So we have to identify, there are 2 chiral centers are there in the substrate. One clearly they have mentioned, but at the third position is also we have one chiral center. That orientation is not clear. By looking at the product, we have to understand. This question is based on the application of the Cramp's rule. So the C double bond O is actually having the diastereotopic faces, because the C double bond O is adjacent to the chiral center, and when the lithium aluminium hydride, the reagent which is the hydride donor, the reagent is the hydride, it has come, if you investigate the product, hydride means hydrogen in the new chiral center, means at the C2 center it is below the plane. So it indicates the in 1-2 asymmetric induction, that adjacent chiral center means the C3 chiral center, the small group means the hydrogen is also below the plane. So if we consider that hydrogen at the third center below the plane, then priority is the C double bond to first priority, the long chain is the second priority, methyl is the third priority, hydrogen is below the plane. So 1, 2, 2, 2, 3, it is anti-clockwise, means the third center will be having the S absolute configuration. So the option will be either 2, otherwise the 4. So if we do the sixth center, which is also a chiral center, that is the long chain is the first priority, ethyl is the second priority, methyl is the third priority, hydrogen is fourth priority, which is at the back side. So here also 1, 2, 2, 2, 3, it is anti-clockwise. So the sixth center is also having the S absolute configuration. So therefore our final answer is 2 and not 4. Now coming to the next question, in the 2013 we have to identify the relationship between HA and the HB. As a whole, this molecule is achiral molecule because the 2 phenyl groups are above the plane and it has the sigma plane. So this molecule is achiral, and if we go to the HA and HB, they are of type CABXX type. So therefore HA and HB are enantiotopic. If we remove HA and the HB one after another by deuterium, we are going to get chiral center. Hence these two are enantiotopic. Now coming to the next question, the Gauche conformation of N-butane possesses that is its so it does not have any plane of symmetry and it also does not have any center of symmetry. So because of that, first option, third option and the fourth option all are out. So the correct answer is the second option, means it has the C2 axis and it is chiral. Now coming to the next question, it's actually an IUPAC nomenclature question. but it is a combination of the stereochemistry. So that's why let us consider the second position in this given compound, that the chiral center is there, and in between the third and the fourth carbon there is a double bond. So we have to take care the second chiral center, and we also have to give the EZ nomenclature for the double bond. So the OH is the first priority, the long chain is the second priority, methyl is the third priority, hydrogen is above the plane. So if 1 to 2 to 3, that is moving in a clockwise direction, but hydrogen is above the plane, so the opposite answer will come. So this is answer will come. Second position chiral center absolute configuration is S. So therefore first option and the first and the third not possible, either answer will be 2 and the 4. So if we go for the E and Z nomenclature for the double bond, it is very clear that is the E. So therefore our final answer is the 4, not the 1, 2, 3. So now coming to the one numerical based on the optical rotation in the year of 2012. In this question we are using a very important formula, that is optical purity is equal to enantiomeric excess is equal to alpha observed divided by alpha theoretical multiplied by 100. Now the first time when we are applying, in this case 90% is the optical purity, and the alpha observed is equal to 135 degree, and we are calculating from this equation alpha theoretical. After calculating this, it is coming as a 150 degree. Now next, when we are applying, that is the various data are available, what has happened after 1 hour of this reaction. In that case it is given that alpha observed is equal to 120 degree, and we have to calculate the optical purity, because by using the this formula already we have calculated alpha theoretical is equal to plus 150 degree. So if we put it into that same equation, then it is coming 80%. So based on this answer, finally the answer will be 1, otherwise the final answer will be 3. So in order to know whether answer will be 1 or 3, we have to go to the next part, means we have to calculate after 3 hours what has happened. Now in that case it is given that optical purity after 3 hours it is the 40%. So we have to calculate the alpha observed. So this is when we are calculating all these things, then it is coming alpha observed is equal to 60 degree. So therefore our final answer is 1 and not the 3. Now coming to that another IUPAC nomenclature which is based on the stereo center, appeared in the year of 2012. So it is first we have to do the absolute configuration of the chiral center. Ester is the first priority, double bond is the second priority, that ring key opposite side where we have the saturated part, that is the third priority, hydrogen is the fourth priority. The fourth priority group is pointing down, so therefore 1 to 2 to 3, this is anti-clockwise, so therefore the absolute configuration will be S and not the R. The R absolute configuration is given in the option 1 and the option 3, so they will not be the answer. Answer will be either the option 2, otherwise option 4, because in that case the chiral center absolute configuration is given S. Now this compound is a bifunctional compound, means it has the ester and C double bond O. So in between these two, according to the IUPAC nomenclature, ester will be the main functional group, and the C double bond O will come as a prefix, ester will come as a suffix. So that is only available in the option 2, not in option 4. So therefore our final answer will be option 2. Now coming to the next question, appeared in 2012. The question is based on the topicity. In the given compound, there are 2 hydrogens are there labeled as HA and HB. Similarly, there are 2 bromines are also there, Br1 and the Br2, they are labeled like that. These 2 hydrogens are geminal, whereas 2 bromines are vicinal. Now we have to identify the topic relationship between these 2 homomorphic hydrogens and homomorphic bromines. Now first coming to the topic relationship between HA and the HB. HA and HB are diastereotopic. Why? Because in this compound the 2 methyl groups are cis and the 2 bromines are also cis. So therefore it is the cis cyclopropane derivative. So in that case HA, if we replace it by D, that will be cis 2 bromine and the trans 2 methyl. Similarly HB also, if we replace it by D, that will be cis to methyl but trans to be bromine. So therefore HA and HB are diastereotopic. Now based on this question, option number 1 and the 4 will not be the answer. Either it will be 2 or 3. So in order to find out the final answer, we have to find out the topic relationship between the two bromine atoms. Now as a whole the molecule is achiral, and in that case the bromine bearing carbon, the substitution pattern is CABXX type. So therefore these two bromine, the topic relationship between these two bromines are enantiotopic. Hence our final answer will be 2, not 3.